And welcome back. Week 4, here we are. We are at that midpoint of our quarter 3. So you want to keep that in mind if you are missing any assignments or need any extra help or anything like that. Hopefully, fingers crossed, this video works when in the morning on Monday and you guys can all view it. We didn't have the extra credit opportunity because it didn't work. I don't know what was going on with it when I tried it, but hopefully Monday in Class Connect I can make sure that I ask you guys this question. 4 articles I chose from sciencenews.org in Science This Week that caught my attention. First article, rings, ripples reveal how long days last on Saturn. I thought this was unique because it's basically about you get 2 Saturn days for every Earth day. So on average, we'll just average it out, even though there's 24 hours on an Earth day. So that's pretty cool. And I also thought it was pretty cool because it brings back, when you know the time of the rotation, they're able to determine the number of layers of the gases before they were able to get to the center of Saturn. And it was back on one of the Cassini, blah, I can't think of the term, it escapes me, but one of the Cassini missions was able to bring back that data. So I thought that was pretty interesting to confirm how long the rotation of Saturn is, because we've always had just an estimate, and now we actually have concrete evidence. Alright, number 2 over here, we're going to just go over here to the right. Ordinary cameras can now photograph out-of-sight objects. Now this right here, I thought, when I read it, I was thinking there was a episode, like, I think it was on Black Mirror, I think, or maybe The Twilight Zone, or The Outer Limits. But there was an episode, or maybe there's like a whole entire series based off of this idea. And it's really cool because it's able to pick up residually what the object was, and the object doesn't have to be there. Okay. And it's done now. They're able, what makes this fascinating is you don't have to have special equipment to do this, to pick up the history of the lights that are there. You can use a regular digital camera and just run it on a program. So remember, all matter, basically everything is just lights arranged in certain fashions, just like you are, just like I am on the atomic and the subatomic level. It's just all different rays of lights, and we talked about that in class a lot. So being able to capture lights that previously were in an area is really going to advance forensic science in solving crimes, because you're going to be able to pick up residual images that are not physically there at that time. So I thought that was one that I wanted to share with you guys as well. Alright, so this one over here in the bottom left-hand corner is, I read it and I'm like, oh, this is the most illogical thing I've ever heard of. But apparently it was very logical at the time. So 50 years ago, scientists tried to control earthquakes with earthquakes. It sounds like something right out of a comic book, right? Like, you know, I don't know, Dr. Doom wants to control something and he like wants to create these earthquakes, and Fantastic Four is coming to save the day. That's what I thought when I first read that headline. And then when I dived into it, it's not a very long reading. I furthermore thought of Dr. Doom. I was like, okay, you know, the amount of energy that one earthquake gives off, they want to control it with other earthquakes. You have to have that same amount of energy being given off in order to control the direction of the earthquake. So, you know, in order to manipulate the waves, they use like water injections and like geothermal injections. That's an intense amount of power. And I just think that that's a use of power that could go to other uses. So, but it's still an interesting read on that. maybe you might think of some comic book character trying to control the earth by controlling earthquakes, and then somehow they have the same amount of energy that an earthquake has in order to control the earthquake. Okay, and then this last article here, it was about penguins. And I chose this one because my son's class Connect he had during the week, he learned about penguins. And it was an informative text. So, you know, he had to identify the parts and stuff. So I was like, oh, this is cool. Let's see what the penguins are doing, right? So I guess the writer of the article just really wanted to stress that young penguins have to, you know, swim in cold water. I read this and I was like, well, okay, well, duh, they're Arctic penguins, so how is this any news to us? Yes, Arctic penguins born in the Arctic must swim in Arctic waters. I'm thinking, okay, they do it while they're young, 5 months old. It's their environment. It was it was one of those chuckle articles that I had read. So those are the 4 articles. Which one was one that your teacher thought was highly interesting and enjoyed reading? And that's how you're going to get your extra credit. Although I guess I could say which one did your teacher think should not have been written this week or not in the news. But that's not what this is about. So for your rest of your information for the week, announcements for January 28th to February 1st. And we're going to have, on Monday, we're going to review the mole island, and you're going to take a quiz on moles. And then on Wednesday, we're going to look at mole ratio and percent composition. On Thursday, we're going to compare molecular and empirical formulas and the procedures on how to complete those. And then on Friday, we're going to just wrap up SC6 and complete all those problems. And voila, that's due on Friday. Easy peasy week, building on what we did last week with moles, getting into stoichiometry, having some more fun there. As always, this is how you contact me. Looking forward to any contact that you do give me. Let's make this a great 4th week. Wow, 4th week! Okay, 4th week. 5 more weeks left in this quarter of school. Bye!